Here's a system of equations that we solved in the previous lesson using graphing. Well, there's other ways to solve systems of equations, so we're going to solve this same system by a different method. The method we're using today is called substitution. Notice that both equations are in slope-intercept form. They're both solved for y. So we can take the right side of one of the equations and substitute it for y in the other equation, as shown. So now we have a new equation. 2/3 x plus 4 is equal to negative 3x take away 7. And there's only one variable. So we're going to multiply both sides by 3 so that we don't have any fractional coefficients. And 3 times 2/3 x is 2x. 3 times 4 is 12. Negative 3x times 3 is negative 9x, and 7 times 3 is 21. And now we'll perform a couple of transformations. The first one is to add 9x to both sides, so we now have 11x plus 12 is negative 21. And then we add negative 12 to both sides to get 11x equals negative 33. We divide both sides by 11. We now know what x is. X is negative 3. And now we're going to substitute again. We take that negative 3 and we substitute it for x in either one of the equations. I chose the equation on the top right. And then I'll rewrite that down at the bottom in blue with the negative 3 already substituted for x. And we're just about out of space, so we're going to do a little mental arithmetic. Negative 3 times negative 3 is 9, and 9 take away 7 is 2. So our value for y is 2. And then we write it, our final solution, as an ordered pair, negative 3, 2. And we're happy because that's the same solution we got in the previous lesson when we solved this system using graphing. Let's solve this system using substitution. Neither one is in slope-intercept form, so neither one is solved for y. This also works well if one of the equations is solved for x. But since neither one is solved for either x or y, let's solve the one on the left for y. So I add negative 3x to both sides, divide both sides by 4. And I now have that y is equal to negative 0.75x plus 3. I take that expression, substitute it for y in the other equation as shown, write it out where I have a little room. Then I remind myself that subtract 8 is the same as add negative 8, so that I don't make a sign error. And now I perform the distributive property. Negative 8 times negative 0.75x is 6x. Negative 8 times 3 is negative 24. My next step is to combine like terms to get 9x. And at the same time, I added 24 to both sides, so now I have 72 on the right side. Divide both sides by 9, and I get x equals 8. And now that x is 8, I can do just as I did on the first example we looked at. I can substitute that 8 for x in either one of the original equations. This time I pick the equation on the left. And I go down here and find some space where I can write it out. And I substituted the 8 in. So I have 3 times 8 plus 4y equals 12. Well, 3 times 8 is 24. And then I add negative 24 to both sides, divide both sides by 4, and I get that y equals negative 3. And then I write my final answer, the solution to this system, as the ordered pair, 8, negative 3. And let's do one more. And this one is not solved for x, it's not solved for y. The one on the right is in standard form, but the one on the left is not in any special form. But we'll take care of that by dividing both sides by 3 on our equation on the left. The 3's cancel. 12 divided by 3 is 4. Now both equations are in standard form. But we're going to solve one of the equations for y so that we can substitute later. And now we're done with the solving for y, that is. And now we take that expression that y equals negative 0.5x plus 1, and we substitute it in for y in the other equation. So now we have this equation. The distributive property tells us that 8 times negative 0.5x is negative 4x, and 8 times 1 is 8. But we see something in our new equation. 4x plus negative 4x is 0. And 0 plus 8, it says, is 48. Or another way to say it is just that 8 is equal to 48. Well, we know that's false. That's how we know that there's no solution for this system. When we solved this system graphically, it was much easier to see why there was no solution. We saw two parallel lines that never intersected. But when we solve using substitution, we don't have any visual representation of the two equations. But when you end up with a false statement, and in this case, that 8 is equal to 48, that's your sign that there is no common solution, and therefore there is no solution to this system of equations. To summarize, to solve a system using substitution, start by solving one of the equations for one of the variables. Replace that variable in the other equation with the expression the variable was equal to in the first equation. Solve the new equation for the other variable, then substitute that value back into either of the original equations to solve for the other variable.